Test, test. Yes, can you hear me? Good morning, everybody. You can't hear me? They can't hear me. Now they can, I think, yes. Good morning, everybody. I first want to thank the organization for inviting me to come and speak here. I'm really excited to, to talk about what we're doing at Nissan and maybe share some, some cool things that we've been working on. I'm going to try to explain to you what it means to bring autonomous vehicles in real life. What are the problems and how we're thinking of solving them. So let me first go back and give you kind of like a roadmap of what Nissan is working on in terms of autonomous vehicles and when they come to market. Today, you can buy what we call ProPilot on a Leaf, on a Rogue, or on an Altima, right? This is what you can go to the dealership today and buy it. And what it allows you to do is drive on the highway, hands-free in one lane, okay? That's what is out there today. What will come next is that we will allow you to drive hands-free on the highway and the car can autonomously change lanes for you, right? So while now you drive in one lane, the next version will allow you to change lanes autonomously. This is, of course, a more difficult problem to solve, right? Beyond that, we're going to bring that technology into urban settings, into downtown Nashville, where you can be in the car, hands-free, but eyes on the road, right? This is really where we still have the human driver behind the steering wheel, paying attention, and always being ready to take over the steering wheel, right? That's what we say eyes-on autonomy. This, the research center in Silicon Valley, delivered to what we call advanced engineering in around early 2017, right? So from the research point of view, driving hands-free in urban environments is done. We have delivered it. Product is now taking this, advanced engineering is taking this to the next step. What we are working on in Silicon Valley is beyond eyes-on driving. We call it eyes-off driving. So that will be hands-free and eyes-off, driverless autonomous vehicles. That's when you can get into services like robo-taxi or robo-delivery services, right? So that's where we are today in Silicon Valley working on. Somewhere in the 2020s, we expect that this kind of autonomous vehicle will be on the roads. So that's where we are. What I'm going to focus on today is on that part. What does it mean to bring autonomous vehicles, driverless autonomous vehicles? A little better. This is a little better? All right. Do I have to start over? No, I don't have time to start over. All right, so I'm going to talk to you about what we're doing for driverless vehicles. So when I came to Nissan to start this program on research and autonomous vehicle, I had experience working at NASA, and one of the things that I started working on very early on, I said, what we need is a concept of how autonomous systems and humans will interact. And I created this concept called socially acceptable driving, right? Or socially acceptable autonomy. How can we make autonomous systems live with humans in human environment? And really the essence is that humans are the best autonomous systems we know of. But they are social. Humans work together. Humans do teamwork. There's almost nobody who does things by themselves, right? Even Tom Hanks in the movie Castaway created the volleyball to talk to Wilson, right? We are social, we communicate, and we interact with each other. So if we want to have autonomous vehicles do that in society where we have humans interacting with it, the system needs to understand those kind of principles. And that's what we call socially acceptable. They have to be socially acceptable so that you can accept these systems driving on the road with you, right? And this is not just for people that are inside the vehicle. More importantly, this is for people outside the vehicle, other drivers, pedestrians, bicyclists. That's the problem that we're trying to solve. And we do that by using social science. When I came to Nissan, the first thing I did was hire a group of social scientists, anthropologists, sociologists, people that have studied how to study people's cultures.
how to study human behavior at large in the wild. And these people go outside and interview and observe and videotape how we drive in the world. And from there, we try to create systems that can do something like that. So let me show you a little video. It's 20 seconds. It goes by very fast, of an intersection in Silicon Valley, right? It's a normal intersection, a four-way stop intersection. I want you to observe, maybe count how many interactions you see there. So here we go. I want you to take a notice of that pedestrian with the yellow circle and the fighting going on with that white car there. But at the same time, you see the other two cars fighting with each other. Who goes first? Who goes second? Right? And then what you will see is the pedestrian running across the road. And now watch these two pedestrians coming here and the woman pulling her husband or a friend back because she's afraid that that car is going to cross the road. This is 20 seconds. Have you counted how many interactions there were, humans actually communicating? What you maybe didn't see on the video is that actually the driver of that car, to the right there, actually waved them on, right? Another human interaction. How will the autonomous system do this on the road? These are the essential problems that we have to solve when we talk about driverless cars, right? And it's not easy. So let me now show you a little video of our system in Silicon Valley. And it's just going to be, again, a short video, but it gives you the essence of how we implement what we call socially acceptable or human-like driving. So what you will see is a video from the autonomous vehicle going towards a stop intersection, actually a three-way stop intersection, and then deal with human behavior where humans will never do what the law tells them to do, okay? And I will have to start this video. So just to explain to you, here you see an interface of the car from within the car itself. You see here the stop sign, you see it sees the other car in front of it. This is the autonomous vehicle. This is the path, the blue path is what the car is driving. On this side, you see, oh, you can't see my mouse, sorry. On the top right side, you actually see the reasoning going on inside the system. It's difficult to explain what's going on. You're not supposed to understand it. Just it shows you what actually is happening. And then let me show you what goes to happen. So the car is coming to a three-way stop intersection. So here you see the car driving. And here you see at the top side, there's already two bars there. It says stop. What it actually is thinking about is that potentially there are two other cars coming at this three-way stop intersection. So it's already reasoning about the fact that it might see other cars. It hasn't seen them yet. That's why there's a question mark. But it knows that this is a potentially that's going to happen. So the car keeps driving. And now you see that the car knows it's coming to the stop intersection. And there, other cars show up. So here it has seen the other two cars. And so you see it now shows these other two cars at the bottom. It says, I gotta stop, okay? So it stops, and now it figures out who's gonna go first. Based on what it has seen and interpreted, it has decided, I was there first. The rules of the road say, who goes first, if you come together, has the right of way. So it will say, I can now go. Now this is where humans don't follow the law, right? So what you will see is that one of these cars is going to do something that we all do, right? But that is not allowed, and the car needs to deal with this. So let's watch. So it goes, I think. Oh, I knew this was going to happen. Okay, here it goes. The car goes, and up, there is the car who's breaking the law. And what it's doing, it's slowing down. It has seen the yellow edging, so it's now going into this behavior that we do all the time. It's like we slow down, but we kind of go so that the person can free the road, and then it can go on. So that's what it's doing. It's seen the other car too, and it takes the left-hand turn. Okay? Now this is just a small example of how we can deal with human interaction and how we deal inside the autonomous system in a probabilistic way with the uncertainty on the roads. So this is just one example. There are many, many other examples we need to deal with and we're working on. But now let's go one step further. So let's say we've solved this problem. Oh, what about this situation? So I took these pictures out of the front of my car myself. For you, the right-hand side, or the left-hand side for you. This is in the Mission in San Francisco. I drive this intersection every day. I know that is a busy intersection. There is a red light. I need to go straight. Nobody tells me what to do. It took me 2 red lights to decide, as a human driver, what to do. Right? I couldn't go past on the right. If I go to the left, I cross the double yellow line, which is breaking the law. I know that pedestrians might cross that I can't see there. And these guys are just working on the trolley lines. So the way I solved this problem is I gunned it. I have a Q50, Infinity Q50 Red Sport, 400 horsepower. I was across that intersection, in no time. But the autonomous vehicle can't do that, right? I mean, do we allow the autonomous vehicle to break the law by crossing the double yellow line? How do we solve this problem? On the other side, that was the next day, Palo Alto, California. For those who University Avenue is a couple of blocks down there. Here I'm already driving on the left side, on the wrong side of the road, so I broke already one law, right? And as you can see, traffic light is red, and the car in front of me is driving through red. Because the person standing there, if you can see it, was waving him on, right? How do we let the autonomous vehicle do this? So these are exceptional situations in cases where things are not normal. How many of you have gone and taken an Uber or Lyft to the airport? Right. Have you done it in San Francisco? This is what happens in San Francisco at 11 o'clock at night when you try to get your Uber, right? I mean, it's a mess. Just trying to find the Lyft or the Uber driver that is yours is. But now imagine that you are a driverless vehicle and have to maneuver through this, through this mess. And on the other side, this was me taking a picture in New York City. And I watched this taxi driver in a Nissan taxi come across on Canal Street to try to get to these passengers, and then he had to get out and help the passengers get in the car. These are, if you want to do robo-taxis, right, driverless taxis, you got to solve this problem. All right, so what do we do? How do we make this work? So I came from NASA to Nissan, and NASA is kind of like our neighbor, NASA Ames Research Center. And so what I did is I went back to my NASA colleagues. And I started looking at how do humans, society today, solve problems with safety in traffic situations. And there's 2 examples that I knew of coming from NASA. One was how we today manage robots on Mars, right? The other one is how we manage the airspace today with pilots and air traffic control. So if you think about robots on Mars, what is common about robots on Mars and autonomous vehicles is that in this case, going to Mars, we can't drive the robot with joysticking the robot, right? It takes 3 to 7 minutes to communicate to Mars from Earth. So we can't just, steer or joystick the robot. We need to send the robot a plan, and then after 7 minutes, when the robot has received the plan, it can execute the plan autonomously. That's how we control robots on Mars. What is also common is that the robot sends all its data from its cameras and from all its sensors back to Earth. And then we interpret the data, we create another plan, send it up to the robot executes it, okay? But what is different between Mars and Earth is that here on Earth, we can communicate relatively fast to the car. right? If we go on the other side to air traffic control, you have the same thing. The plane is always flown either by the pilot or by the autopilot. It's not flown by the air traffic controller, right? The air traffic controller talks to the pilot and tells the pilot what to do. So these are some of the examples that we've used to come up with how can we do this with autonomous vehicles? Isn't this in here somewhere a way to solve this problem with autonomous vehicles needing to have help from humans in order to solve these difficult problems? So that's what we have developed. We have developed a system we call SAM. And what the system is about allowing a human at a distance to interact with the autonomous vehicles in situations that are problematic. Now, what we've taken from the Mars rover is the software that they use to communicate and do this with Mars rover. So we will always let the autonomous vehicle drive autonomously. We are not joysticking a car at a distance, right? So the car is always autonomous. The human helps the car to make what we call go and no-go decisions in cases where it needs help. So let me give you a little example of a video. What you will see is the two screens of the controller at a distance interacting with the vehicle. On the right side, you will see what we call the fleet management system, where we will see the car driving and asking for help. And then you will see the interaction of the controller on the left side. So here you see the orange little blip. The car asks for help. The controller clicks on the menu. A 3D world shows up where we stream all the data from the sensors, the LiDAR, the video, the radar. It creates a 3D picture. The controller can now interact with the vehicle by drawing a new path, a new way around the vehicle, saying like, it's okay to drive in this road when I tell you to go. When the controller has looked at the video cameras to see what's going on the road, you can see the person with the sign saying, go slow. He can see with the cameras what's going on. He clicks the button, sends the plan to the vehicle, and the vehicle autonomously drives around the obstacle, right? So this is what we call teleoperation. And this is what our image is of how to solve these complex, difficult situations in the real world. When the situation is resolved, we can say, okay, it was a road construction at this point. All the information is now communicated to other cars that are in the area, and we can solve this problem now autonomously. So really what the seamless autonomous mobility concept is about a robust control system that we've taken from NASA, applied to human decision making with human-robot teamwork, and with communication from the cloud to the vehicle, while putting AI in the cloud that allows the vehicle to solve these problems without human in the loop. So this is our concept. We're working on this. We're testing this in Silicon Valley every day on the roads, and hopefully soon you will be enjoying a robo vehicle that you can be safe in and you can really trust to be human-like. So to end, to say, I have a couple of statements that are provocative. We can talk about it. I say, show me an autonomous system without humans in the loop, and I'll show you a useless system. And another thing I like to say is that an autonomous system is more than just an intelligent agent that does things by itself. It's really a holistic system with humans in the loop and AI in the cloud and AI on the car. So with that, I thank you very much and hope to answer some questions.
Now you know why Maarten was named by Fast Company in 2015 is the 25th most creative person in business. How about that? Now we know it, and we know what the exciting future holds for us, buying Nissan products. Hey, now we're going to move, and I would ask, I know there's great networking going on. That's a key part of what we're doing at 36A6. We do have about 12 more minutes, and we're going to break for lunch, and there'll be lots of time to talk over lunch, and while you're looking at the Nissan cars down in Innovation Alley. So if we could keep it down, that would be really, really helpful, even on the second and third floor. Okay, with that, I want to introduce my boss, our board chair, Bobby Rolfe. And as I mentioned, ECD is a great partner for Launch Tennessee, and without their support, we wouldn't be able to do the kind of programming we do to help entrepreneurs. Wouldn't be able to do 3686, and it goes beyond a financial partnership. We've got a bunch of folks from ECD here who have become friends and partners in what we do, and we so appreciate our relationship. And Tennessee has been so fortunate where we have business folks who are willing to take a time out on their business interest to come give time and service to the state. And Bobby's only been in the role for 17 months, but he's given at least 3 years worth, I promise you. Because I know he's been overseas about 15 times. Plus, he works nonstop. He's also become a great friend. So please give it up for Bobby Rolfe.
Well, ladies and gentlemen, almost good afternoon. Maarten, thank you very much. Ladies and gentlemen, what I think you just discovered is this truly is rocket science. And we say that because when we think of the automobile and we think of Nissan, Nissan is quickly becoming a technology company. And so I'm going to take the privilege here and spend the next 10 minutes or so asking Maarten a couple of very interesting questions as opposed to a Q&A because we were limited on time. So, Maarten, tell us a little bit about all of the new innovations over the last decade. They've happened within the startups that then bring their development ideas to Nissan. Your responsibility is to vet those. Tell us how you go about that process.
Yeah, it's actually very difficult to bring innovation from startups to large companies like Nissan. And the reason is, to me, is a good collaboration with any group, right? And you've seen already, I'm all about collaboration and teamwork. A good collaboration is a win-win for both parties. And it is always, as a research side for me, very easy to define the win for me. Because a startup might have some great new technology that if I can take that technology and use it within Nissan, that'd be great. I don't have to create the technology, I can focus on something else, that's great. But what about the startup, right? A startup has 18 months of runway to bring a product to market. And in a large company like Nissan, that is not an easy thing to do because, as you could see, it takes years for a car to get to market. So I think the challenge for Nissan is to open up its doors to allow this fluid interaction between a company like Nissan, its research in developing it to be innovative, to develop new technology, and a startup that needs to have a product go to market, otherwise they die. And so that's what I'm trying to do, and I pick startups that really solve a problem that we don't want to solve, right? Those are the startups that I pick out, and I say, come and work with us, let me do a POC together to bring in the technology, and then you can use it as a startup in your communication to your investors, to customers, to say, look, Nissan is using our innovation to build a product. But then you need to go out and build that product with other people too. You can't just rely on Nissan to do it with 18 months because that's not going to happen.
Thank you. Excellent. Okay, so of some of the biggest challenges that startups in this room face, working with a large global corporation like Nissan has to have its own set of challenges. So when a startup brings an idea to you, this is a startup with an idea that's been outsourced beyond the R&D channels within Nissan. How do you go about that process? And is it an open door? Do you give out your email, your cell phone? How do people present?
Yeah, it is. So we have changed a little bit how we're doing this over the last couple of years. In the beginning, we were developing this autonomous technology, and it's like you need to crawl before you walk, right? We're now ready to walk, but there are some things, as I mentioned before, that we don't want to solve. We want to do the AI, the decision making, the interaction. We don't necessarily want to solve the perception problem. So what we do is now we find out which startups are out there in the world. I mean, we're not just looking at Silicon Valley, we're looking at all over the world and find those startups that can really solve a particular problem, bring them in, create an agreement between the two of us, and then together we implement their software, for instance, into our vehicle, and then we go test with them. And this allows them to, drive a vehicle on the real road with real automotive people to tell them what to solve, what problems they need to work on. And this becomes a partnership, an innovative partnership that I think is actually helping both sides.
Thank you. So, Maarten, you have been with Nissan 5 years.
Yeah.
An incredible...
It's amazing.
An incredible NASA experience. You started, you were part of a co-founding and operating partner for a healthcare AI company.
Yes, although...
So in the last 5 years in your new role, what are some of the big shifts that have happened from when you showed up 5 years ago to today inside of Nissan?
Yeah, so that's a fascinating question because I think about this. I mean, 5 years, in my life I always said, don't stay anywhere longer than 10 years. Then you got to move on to something else, right? So 5 years, that means I have 5 more years to go before I could say that. When I came to Nissan 5 years ago, autonomous vehicles, yes, we believed that this was coming, but nobody really had showed these vehicles on the road in real life driving. So what has changed in these 5 years is that the situation has gone from imagination and a couple of smart people at universities being able to demonstrate some things in the desert to actually many, many companies testing this technology out on the road. And the whole company, all automotive companies are now behind this idea that this is becoming reality. And for them to be part of it, they gotta innovate and they gotta be part of this game. Otherwise, somebody else will do it for them. And that has created a real shift from, to an urgency in the company to really make this happen. And I think that is a fascinating process because, like I said before, Nissan is a global, huge company, right? To get everybody to focus on that part is quite a difficult challenge.
Outstanding. Okay, if some of the projects or initiatives that really excite you, give us a little bit of inside baseball of exactly what they are that you could talk about, that really you have a passion for as you and your team are truly transforming the automobile industry.
Yeah, I mean, you kind of, I hope I got across the passion that I have for building autonomous systems. For me, the passion is to solve, artificial intelligence and computer technology can be used for many, many things in the world. I am somebody who says, if you do something as a technologist and bring this to the world, you have to do it for the good of humankind. So the passion that I have, both in my startup where I solve healthcare problems, at Nissan, it's about solving problems to allow people to have better transportation, people that cannot have transportation today because they cannot drive for whatever reason, would be able to have mobility services. That to me is what drives me to use AI to solve these human problems. But then we have to do it in the right way. And to me, the right way is to really understand human behavior and put the human at the center of this problem all the time. The human should not have to adapt itself to technology. Technology should be smart enough to understand what humans are, how humans behave, and what humans do. And this is what my passion, this drives me.
Thank you. All right, so you were in what we'll call the VC world for life prior to Nissan. You transform into what is a corporate environment at Nissan. And as you process life today, what are the differences between having your own shop versus having a boss and having a board and having such an initiative that is truly going to be transformational when you complete this project? So would you tell our audience a little bit about what some of those differences are and how you have made that change in your life?
Right. Let me start by saying what the similarities are. And then I'll go to the difference. So the similarities are that you always have a boss. Don't think you do not have a boss when you have a startup. Your VCs, your investors, are your boss, all right? they want to make money out of you making money. So you got to listen to what they say in the end. So, and then you have a CEO. If you're like me, I'm not, I'm a technology guy, so I'm not the CEO. So my CEO is the boss, all right, in my startup. She actually tells me what to do and what is going to happen. I just follow. The other thing I would say is the same, is the passion. It's like, I don't care if I'm at Nissan or am I at my startup at night thinking about what we need to do for solving healthcare problems. If you don't have passion in what you do, you cannot change the world, right? So to me, that's what a startup is about. You have to feel passionate. To me, it was when I did my PhD. I always said to my students, if you're not passionate about what you're studying and what you're researching, don't go do your PhD. It's a freaking misery for 5-6 years because nobody will tell you what to do, right? A startup, nobody will tell you what to do. You got to do it yourself. At Nissan, yes, you have a boss, but nobody will tell you what to do in order to solve a problem with autonomous cars because one person has the answer. And so if you don't have the passion to work at it and do what you think is the right thing to do, nothing will happen. So the difference is, in a startup, you have, well, if you're lucky to get funding in your seed round, you have 18 months. If you're unlucky, you have 6 months. You gotta solve the problem, create a business, define how you're going to make money, and solve the technology problem to survive. That problem does not exist at Nissan. The urgency is not that high, right? So that gives you more time, to think, more time to work across the politics, right? It is not as, yes, the pressure is there, believe me, to make these vehicles drive on the road by 2022, 23, that's not long, right? So we do have pressure, but it's not a 6 months pressure. And what I have learned being in a startup is that it is not about technology. It is about defining your business model. And that I take back to Nissan because I suddenly appreciate being a researcher at Nissan or wherever I was, where I always thought that the technology is what is really the big thing to solve. Now it's about communicating your solution to your stakeholders, to people that need to help you implement what you have designed. And so, I use the fact that I know that the business, how to make money, is what drives a startup, is also in the end what drives Nissan. And so that to me is actually, stimulating on both sides.
So ladies and gentlemen, we are just about out of time. And what I would like to say, Dr. Sierhuis, is thank you very, very much. For those of you that are not a part of our Tennessee community, Nissan has been a fantastic partner. The North American headquarters 12 years ago moved here from California, and Scott Becker, the Chief Administrative Officer, who's been very instrumental in making sure that we could hear from you today, and thank you very, very much. So ladies and gentlemen, a round of applause for Dr. Sierhuis.
Thank you, and for those who are in startups, good luck.